solving differential equations. Again, this is not completely new. We've done a little bit of this already. In fact, this would be the problems on the test where it said f double prime was equal to 2x, find f prime. So you have to integrate and use the initial conditions. So we've done solving differential equations a lot. What we've just started this unit is the by separation of variables part. It's nice when the name of the method explains what to do, right? I feel like that's pretty rare in math. Usually there's a crazy name named after the guy who figured it out. Here, the name of the method is what you do. You separate the variables. By the way, so we're spending like a week on solving differential equations. A little side note here. Calculus 1, that's AB calculus. That's what you're in now. Cal 2, that would be if you were taking BC, you would get Cal 2 credit. In college, you can get to Cal 3. And then after Cal 3 comes differential equations. So we're spending a week on it, but there's a whole semester-long course on what we're doing in a week. So if you feel like, hey, this isn't too bad, you're right, but it can get really complicated. And then if you really want to have fun, you can take partial differential equations, which we don't really even know what that means right now. So there's your math track if you're headed toward a math or STEM field, engineering, math, something like that. You could be headed this direction. What's that? I went to partial differential equations. I did not do linear algebra. The difficulty of linear algebra, I think, is somewhere back in here, though. It's not too bad, difficulty-wise. Then there's other math courses that are not sort of in this chain of things, like geometry-type math courses. But I took a few of those. But mostly, this is the chain for math, science, or for science, for engineering-type majors. Math people, they would branch out and do matrix stuff, linear algebra, topology, a lot of different weird stuff. But the comment for those at home was someone is so excited to not have to do those, which is also great, right? Like, that's the beauty of dual credit. Some of you are taking your dual credit and saying, adios math, I'm out of here, and that's fine. All right, the first type of question we're going to do is a verify question. So they're going to give you the answer, and they want you to show that it works. So sometimes I skip over this example, and then when students hit one, they don't know what to do, even though it's an easier problem. Verify that y equals e to the negative 2x is a solution to 3y prime plus 5y equals negative e to the negative 2x. Okay, that's a differential equation because it has a differential in it. It has a derivative in it. So we do not know how to solve this differential equation. We definitely don't know how to solve this one because we couldn't really separate the variables. But we're not asked to solve it. We're just asked to show that that thing works. So all I have to do is plug that thing in and see if everything works out. So y is easy. They told me what y is, but I need to know what y prime is so that I can substitute it for y prime. So let's find y prime. Derivative of e to the negative 2x is e to the negative 2x. But what else? Yes, chain rule, negative 2. So now I know they gave me y, I found y prime. Now I can just plug those in. And it says verify. It doesn't even say see if it works. Verify means it works. Just show that it works. So 3 times y prime, negative 2 e to the negative 2x, plus 5 times y, e to the negative 2x, is supposed to equal negative e to the negative 2x. Well, let's see, negative 6 e to the negative 2x plus 5 e to the negative 2x. That does in fact equal negative e to the negative 2x. So most of our problems are not like this one. Most of our problems are, we're going to give you the differential equation and ask you to solve it. But occasionally they could ask you to verify one, but we like that. All right, let's do some problems. Some of these we've kind of done before. All right, let's jump to y prime equals x times 1 plus y. Solve for y. So it's a differential equation because there's a derivative in there. A lot of times it helps, instead of, like, usually you like y prime rather than dy dx because it's just easier to write. But when it comes to separating variables, it might be better to write dy dx, because then it's a little bit more clear about who's y and who's x and where they go. So let's move the 1 plus y over by dividing it. Move the dx over by multiplying it. And that's the name of the method, separate the variables. And then integrate both sides. And so in some sense, all of these differential equations turn into two integrations. You got to integrate the left and integrate the right. And sometimes one side is easy, sometimes both sides are easy, sometimes both sides are hard. Which side's easy on this one, do you think? The x. Because what's the antiderivative of x? 1/2 x squared. And we need a plus c on one side or the other, and we usually put it on the x side. It doesn't matter, but just kind of habit, that's usually where it goes. How about the other side? Let's use u substitution. What do you want to use for u? U equals 1 plus y. Du equals dy. And so that gets me the integral of du over u. Kind of like that. That's good news. What's the antiderivative of du over u? Natural log. So natural log of u equals 1/2 x squared plus c. Let's put the y stuff back in there. So natural log of 1 plus y equals 1/2 x squared plus c. Okay, the calculus part of our problem is over. We're done with calculus. But we're not done with the problem because it said solve for y. So we're maybe a little more than halfway done with the problem, because now we've got to do the algebra to get y by itself. And this is, for some, the harder part of the problem. Like, we've done all of that stuff before. That integration of x was no big deal. That u substitution hopefully wasn't too bad. Now I got to figure out how to get y out of this. Any thoughts? How do I undo a natural log? Maybe I could ask it that way. What do you mean a function?
Like, some of a number is like enough constant. Like, natural log
Natural log
is
is a function. I need a function. I need the function that undoes that. Just like square undoes a square root. I need an inverse sine undoes sine. But what undoes natural log? Okay, it has to do with e. There's two ways to do this. You can just do e to both sides. That would do it. Or you can do the fishhook thing. And I feel like most students are more familiar with the fishhook, so we'll do the fishhook. We're going to rewrite this as a exponent rather than a log. So there's that invisible e is the base. E to the other side equals 1 plus y. So e to the 1/2 x squared plus c equals 1 plus y. We still haven't finished because we need to solve for y. So y equals e to the 1/2 x squared plus c minus 1. That's sort of not sort of, it is a safe stop, but not best stop. Because what we do later, there's a better way to write it. So that's not wrong. We could stop there and be okay. But when we hit some problems later, it's going to be much better if we wrote this a different way. Let's back up and remind ourselves of some things here. What's x squared times x to the 5th? X to the 7th. So you added the exponents. What we're going to do now is sort of unadd these exponents. Somebody added these exponents, and so I could rewrite this, and your initial reaction is probably like, why in the world would you do that? But are you okay with that mathematically? Like, that's the same thing as this property up here. 2 plus 5 is 7. 1/2 x squared plus c. Combine them together. Remember, c is any number, so we haven't figured out what c is yet. E to the c then is any number, so I'm going to call that a different c. Call it c1. E to the 1/2 x squared minus 1. And it's just a whole lot nicer if the constant you're looking for is a coefficient rather than part of the exponent. So you almost always want to get it to this spot, because then when you have this one didn't have a specific solution to plug in and find, but if you did, this would be a lot easier to deal with. So there's a lot of algebra in there. The e fishhook thing to fix it, to turn it to y equals, and then a little bit of algebra trickery to turn that thing into a coefficient rather than an exponent. We'll get more practice on that, because a lot of our problems end up working out kind of like that. Let's do one more together, and then we'll do one off the worksheet if we have time. Y prime equals 3y plus 6. Solve for y if y of 0 equals 7. Okay, so this is one of those what we call initial conditions. Used to find c. It's also like, if tying it back to slope fields, it's where to start on a slope field. So we put 0, 7 on the slope field and kind of go from there. Okay, so this one has all of the fun of the last one, plus at the end we need to figure out what C is. So first thing I'm going to do is rewrite this as dy dx so I know how to separate variables. Okay. Any idea on how to separate these variables? You know what, let's multiply the dx over first, because I think that will help. I want to get the y stuff over. But there's two options, and one I think is better than the other. I can divide by 3y plus 6. That would be fine. Anybody know of anything else we could do? An algebra step we could do first? Just looking at 3y plus 6, what could you do with that in 8th grade maybe? GCF, factor it. And that'll make our life a little easier if that 3 is with the dx rather than in the denominator over there with the y. So it would still work if you divided by 3y plus 6, but it will make your life a little easier if you will GCF that thing and leave the 3 with the dx. Again, don't have to, but it makes life better later. All right, I'm going to hit pause. Why don't you integrate both sides? I'm even going to do this one without use substitution. Well, sort of use substitution in my head. It's going to end up being natural log y plus 2 equals 3x plus c. Let's see. Oh, now how do I get y by itself? Here comes our, now for the algebra part. The fish hook thing. So e to the 3x plus c equals y plus 2. So y equals e to the 3x plus c minus 2, which is okay, but not best. What's the trick we're going to pull here? Basically, that c can be a coefficient c. It'd be a different c, but since we haven't figured out what c is yet, it doesn't really matter. I'll call it c1 just because it's not the same number as the c in the exponent. Okay, so that's some important algebra steps in there that, you know, this is one of those places where the students get the calculus right and then algebra, oof, sometimes. All right, I'm close. What else? What's left? What's left to do with this problem? Use that point. And that point was 0, 7. So 7 goes in for y. 0 goes in for x. So 7 equals, what's e to the 0? 1. So this works out pretty nice, and it works out that way a lot of times. A lot of times we give you 0 for x, and so it makes the math a little easier. So c1 equals 9. So y equals 9 e to the 3x minus 2. A lot of calculus, a lot of algebra. in those problems. I'm giving you a worksheet. Today assignment is 1 through 8 on the worksheet. Block day assignment will be 9 through 16, and we'll have time to work on that together. I'm going to pass it out, and then we're going to do number 6 together. So there's number 6. And again, working on notebook paper. Do not try to fit it in there on the page. I guess you could do it on the back, but even then you probably couldn't fit all of them on the back. Solve the initial value problem by separation of variables. So separate the variables, and it gives me an initial value so I can find C at the end of this problem. So job 1, get all the y's together and all the x's together. So dy over square root of y. The constant you can use on either side. So it's just, would you rather have a 4 in the numerator to deal with or a 4 in the denominator to deal with? Probably the numerator and probably the x. So you could put 4 in the bottom over here, but I'm going to leave it on the x side. Integrate both sides. I'm going to put the antiderivative sign after the 4 just so that I'm not really worried about the 4. Okay, on the left, I don't like roots, right? I can't derivative or antiderivative a root. I need to write that as a power. So what power would that be? I'm going to go negative 1/2 since it's in the bottom. And I'm gonna focus on the left-hand side for a minute, and we'll go back and do the right after that. So increase the power by 1, divide by the new power. So that wasn't too bad for the left-hand side. For the right-hand side, how do I integrate? Any thoughts on how we could integrate natural log of x over x? You see anything that would work well for a u such that du would show up? Yes? Why natural log? Because its derivative is 1 over x. So you have to know the rules well enough to look at that and think, oh yeah, the derivative of natural log is 1 over x, and there's a 1 over x sitting there, so that'd probably be a good choice for you. So the 1 over x dx is the du, and the natural log is u. And now that's an easy problem. What's the antiderivative of u du? 1/2 u squared. So 4 times 1/2 u squared plus c. Again, it doesn't really matter which side you have the plus c on. So let's see. So 2y to the 1/2. I think my calculus is over. Now it's a matter of taking care of all the algebra. Oh, that was kind of convenient of them. What can I do next? What's convenient? What's working out here? Yeah, I can divide by 2. Make life a little easier anyway. Y to the 1/2 equals natural log of x squared plus c. We have options now. I could square both sides to get y by itself, or I could plug in this point and find c. It doesn't really matter. I think for this one, I want to plug in the point first. I'm also looking at, if I plug in 9 for y, I can take its square root, and I have a little bit easier thing to work with here. So e comma 9, so 9 to the 1/2 equals natural log of e squared c. Yeah, our calculus is over. We are now algebra only here. What's the natural log of e? 1, and 1 squared is 1. So c is equal to 2. So y to the 1/2 is natural log of x squared plus 2. And I guess we should get y by itself. So let's square both sides. This looks a little bit weird maybe, but there's my answer. Alright, again, today's assignment is 1 through 8. Block day's assignment, 9 through 16. So by Friday, hopefully you have them all done. So that kind of gives you some days in there to play with, to figure out, what's best for your schedule. Do you need to do them all tonight? Do you have something going on tonight and you need to do them all Wednesday night? I don't know. You figure it out. Please have some of them done by tomorrow. That way you can ask some questions. So attempt some of them, at least. But other than that, you figure out the best way to manage your time so that everything gets done.